situations. There are different situations in differentiation. You can have a situation where you have y equal to u plus v, a situation where you have y equal to uv, and a situation where you have y equal to u over v. Now, this situation where you have y equal to u plus v, it has to do with addition. What about a situation where you have uv? That has to do with products. Then this other one has to do with division, and we can call it quotient, division rule. So we take it step by step in the easiest way possible. Start from the first one. If you have this situation, y equal to u plus v, you just differentiate u. So you have du dx plus dv dx. So you differentiate what you have, then you differentiate the other aspects. So let's say, for example, you have a situation like this. You have so you have 3x y equal to 3x plus 3x squared plus 3x. What did we just do? To get the y dx, all you need to do is to say, 6x raised to power 2 minus 1 plus, you know that is 3. This is raised to power 1. So you just write 3 times 1 x 1 minus 1, and this will give you 6x raised to power 1 plus 3x raised to power 0. And you know that x raised to power 0 is 1, so you have 3 times 1, and in this case you have 6x. So your answer will be 6x plus 3. So if you solve this, 3x squared plus 3x raised to power 1 to give you 6x plus 3. So that's the first thing. So if you have a situation like this, if you y equal to u plus v, you differentiate in this way, which is what? The y dx equal to du dx plus dv dx. That's the first thing. Then a situation where you have y equal to uv, that's y equal to uv. So in this aspect, you have that the y dx is equal to, you're going to pick v first, v du dx plus u dv dx. So you have v du dx plus u dv dx. So let's give an instance where you have y equal to 2x into x minus 1. Now, to differentiate this, you are told to find the y dx. Find the y dx. Now, when you are told to find the y dx in this situation, all you just need to do, just indicate it. This is u and this is v. So say u equal to 2x. If we have u equal to 2x, we can find the u dx. We differentiate u in respect of x, and you have this is 2 because we have 1 here. And if we even write it, 1 minus 1 is what? 0. You have 2x raised to power 0, and you know that x raised to power 0 is 1, so 2 times 1, and this will give you 2. So in this situation, if you differentiate 2x raised to power 1 to give you 2 as your answer. Then in a situation where you now have x minus 1 as v, so v equal to x minus 1. So if you have v equal to x minus 1, we can have dv dx, and dv dx will be equal to, this is 1, right? So this will give us 1x, 1 minus 1, and this will give us 1x raised to power 0. We know that x raised to power 0 is 1, so we have 1 times 1, which is what? 1. So from here we have dv dx. dv dx is 1. dv dx is 1. dv dx is 1. So to solve this, all you just need to do is come to this formula, which I said is what? V du dx. What's v? Check here for v. V is what? V is x minus 1. V is x minus 1. What's du dx? Du dx is 2. Du dx is 2. Then what's u? U is what? 2x. U is 2x. Then the next part is what's dv dx? dv dx is 1. So you just put 1 here as dv dx. So what you have here is going to give you 2x minus 2 plus 2x, and this will give you 4x minus 2. Check it very well. 2x, 2x. What do you have here? 4x. Then what do you have here? This part, which is y equal to u over v. Now, if we have y equal to u over v, and we are told to find the y dx, we have what we call the quotient rule, which is v, the u dx minus u, the v dx over v squared. So you have v, the u dx, and we have u dv dx over what? V squared. So this one has to do with division. So in a situation where you have something like this now, y equal to 1 over x raised to power 2. We can say 1 is u, and x squared is v. So we can have v over u over v. Now don't make that mistake of writing v over u, it is u over v. So to solve this, you just know that dy dx is equal to v du dx minus u dv dx over v squared. Now in this case where you have u to be 1, like I said, anytime you differentiate a constant, it will give you 0. So we have differentiated u, du dx will give us 0. Now we have v equal to x squared. If v is equal to x squared, we're going to check dv dx will give us 2x, 2 minus 1, to give us 2x, 1. Towards 2x raised to power 1, 2x. Now we have gotten dv dx to be 2x, we have gotten du dx to be 0. So we place it into the formula now. We have that we have v to be x squared. Then we have du dx is 0. Then we have u which is 1. Then we have dv dx which is what? 2x. Then we have v squared which is x squared raised to power 2. Now you know that 0 times this will give us 0, so write 0 minus 1 times 2x will give us minus 2x over x squared raised to power 2, and this will give us minus 2x over x raised to power 4. Well, what we have here is we can simplify this to give you minus 2x over x times x times x. Sorry, let me rewrite this. X times x times x times x, because it's x raised to power 4. So x here 1, we have x here 1. So what we have here is minus 2 over x raised to power 3. So if you check, we use quotient rule to solve this, and we got minus 2 over x raised to power 3. How about we use the normal rule which I also explained? Let's check if we get the same answer. Y equal to 1 over x squared. And from this we know that this will give us x raised to power minus 2. And now if you are going to use the normal method which I explained, y equal to x raised to power n, the y dx give you nx n minus 1. You have minus 2x minus 2 minus 1, which is minus 2x raised to power minus 3, which is minus 2 over x raised to power 3. Remember that this minus x raised to power minus 3, you will need to take this minus 3 down. So if you are taking this minus 3 down, it will give you minus 2 over x raised to power 3. Is that not what we got? Check. Are they the same? Yes, they are. Observe very well, they are the same. So that is one thing you also need to understand in this situation. So you can have the product rule. We can have this addition. We can have the quotient rule. We can have the simple rule which we talk about, which has to do with when we have y equal to x raised to power n, dy dx equal to nx n minus 1. And if you have all that, that is already a plus for you.